Yes, some of you have typed the answer. Maybe when I'll wait for 1 or 2 more minutes so that more people can finish it. Yeah, okay. So let's discuss the solution now. Anybody, so some of you who have got the answer, do you want to explain what was the concept that you used to get the answer? Okay, so I can just discuss the solution directly then. So the question is the recognition site for EcoR1 is GTTAAC. So here it is a 6 base pair sequence that you have to note. And we can assume that all bases appear with equal frequency. So appear with equal frequency meaning that there are 4 possible bases ATGC. So the probability of getting each base will be 1 by 4. And the question is, what is the probability of having no EcoR1 site in a 10 kb long random DNA sequence? So to get this, first we know that each base is as occurring with an equal probability. So the probability of, so first we can calculate what is the probability of getting this GATTC sequence. So here we can, since they have given that it is independent in the solution, here we can use the product rule. You're muted. Yeah, sorry about that. So first we are calculating what is the probability of getting this specific sequence. So for to do that we can use the product rule because probability uh, of the base here will be independent of the probability of the base in the other position. So these are independent events. So we can use the product rule. And so for example, here we are getting 1 by 4 because probability of getting G is 1 by 4. Similarly, probability of getting A is 1 by 4 because there are 4 bases, right? ATGC. So for this 6 base pair sequence, it will just be 1 by 4 multiplied 6 times or 1 by 4 power 6. Will give us the product rule. But in the question they are asking probability that this EcoR1 site does not occur in a 10 base pair sequence. So it is a 10 kb sequence, meaning 10,000 base pairs. And in this 10,000 base pairs, we can calculate total number of 6 base pair sequences. So the total possible number of 6 base pair sequences will just be 10,000 minus 5 because we can from the 10,000 base pair for the first 5 positions we can't have because it is a 6 base pair sequence, so we are just subtracting 5 here. And then we can use the this formula from permutation and combination. And here I can explain it. So n is the total number of combination, which here we have found out this. So that will be 10,000 minus 5. And k basically is 0 here. That we have to, that is given in the question. And p of k is probability of getting this specific sequence. Um, so in the place of p, we have to substitute this 0.25 power 6. So p and then raised to the power k. So p is 0.25 power 6 raised to the power k is 0 that we have got here. And here also we have to substitute these things. 1 minus 0.25 power 6 is the value of p, and n is 10,000 minus 5 minus 0. So basically we are just substituting these values into this formula from permutation and combination. And when you do the final calculations, you will get this value of 0.087. I hope it's clear to all. If there are no doubts, we can go to the next week syllabus then. Okay, let's move on. So in the third lecture, we discussed again probability distribution, but we were discussing for a continuous probability distribution. So continuous probability distribution is used for continuous variables, for example, population height. Um, so given that you have a probability distribution, this formula is saying from the probability distribution how you can get the probability. So for example, if you are having a probability distribution of height, I'm just giving a rough example. Maybe this is like some 4 feet and this is 6 feet, and this value is 0 and this value is 1. So mostly these height distributions will be following a normal distribution. And now you have to find out what is the probability of having a height in between 4.5 feet and 5 feet. So from this we can see that probability of 4.5 will be whatever value is here, and probability of 4.6 will be whatever value is here, probability of 4.7 will be whatever value is here. So to get the probability distribution from 4.5 to 5, basically we have to add all these values. And or in other words, so adding all these values is similar to saying that you have to find the area under the curve for this range. So area under the curve is basically integration, and you have to integrate between the lower limit. So this will be A, and the upper limit, this will be B. And you have to integrate this curve. So this curve is the f of x here. F of x dx. So that's how you are getting this formula. And there are different types of continuous distributions. For example, there is normal distribution, which is a bell-shaped curve. And then you have this is normal. And then you have the uniform distribution, which is just a flat line. So you get this uniform distribution if the probability is equal for all the combinations. And finally, you have the exponential distribution, which is like the e power x graph. So now let's discuss a related problem. So this problem is based on the normal distribution. So given this graph, they are giving a normal distribution is with 21,9. So normal distribution 21,9 means mean, and 21 is the mean and 9 is the standard deviation. So from this we have to find out what is the probability of weight greater than 27 kg. So you can take a couple of minutes to solve this and then we can discuss it.
Excuse me,
Yes?
ma'am, there's a sign which says this call is gonna end in 1 minute.
Okay, let me check.
Yes, ma'am. Could you please check it?
Yeah. Okay. Are you still getting that message? I'm
Yes,
trying
ma'am.
to.
The call is about to end.
Okay, just a minute.